We're asked to draw an energy diagram or an orbital diagram for arsenic, number 33, and then write its electron configuration in noble gas notation. So arsenic, on your test, you're getting this a periodic table like this. So there's arsenic. It's in. This is the 2p section. This is the 3p section, and this is the 4p section. So you'll have to see this, or rather this whole setup, just by looking at the periodic table. That's what we want you to do. Now, if you don't see that, you can simply follow this filling chart, which you are going to get on your test. All right, you just have to know that the s orbitals can hold 2 electrons, and the p sublevel can hold 6 electrons, and the d sublevels can hold 10, and the f's can hold 14. All right, so knowing that, we can write the electron configuration, and it's going to end at 4p1, 4p2, 4p3. All right. So if we were to write the whole, actually let's just draw the energy diagram. All right. So the Aufbau filling principle says fill with the lowest energy. Just fill it according to the periodic table. That's what it says. All right. So there we got 1s orbital. So up here, we've completed that. So when that arrow ends, we go to the next arrow, and that's going to take us to the 2s orbital. And then after the 2s is the 2p, and there's 3p orbitals at every energy level that has p orbitals. And after the 2p is a 3s. And after 3s is a 3p. Follow Hund's rule. Now after 3p, so we've gone there, we've gone there, we've gone there, we've gone there. This filling chart tells you you'll go to the 4s, and if you're following the periodic table, you'll see the same thing. After 1s is 2s, after 2s is 2p, after 2p is 3s, 3p, just like you would, but then after 3p, you don't go right to the 3d, you go to 4s, right? 4s. So the 4s can hold 2 electrons, and then we go back to the 3d. And there are 5d orbitals. We're going to fill them up, following Hund's rule. That puts us at 30 electrons. So we've already we've already covered all of that, all the way to zinc, and we need to get 3 more spots over to arsenic. And that's where the 4p's come in. Okay, so we've gone through all the 3ds, right? We've blasted through that. So now we're here. We're not going to fill that up because our element is there, arsenic, and if we were to go all the way to 4p6, that would take us to krypton, and we're not trying to get there. All right, so we need a 4p sublevel. There's 3p orbitals, and 1, 2, 3. Okay, so sometimes students will do this, and that's a violation of Hund's rule. So Hund's rule says maximize the unpaired electrons before you pair them up. So there's your energy diagram. You can do the same thing, and if you don't know how to stagger these, you can just put all of these on top of each other, and that's fine too, as long as you're following the order. Now, the noble gas notation, right? All of this is argon. Right, so the preceding noble gas, so here's arsenic, and the preceding noble gas is argon. So we're going to write that in brackets, and then whatever is remaining, which is the 4s2, 3d10, and 4p3. Right, so there is the 4s2, there is the 3d10, and we're going to end at 4p3. So that's what's remaining after the noble gas. So 4s2, 3d10, 4p3. And there's your noble gas notation. If you want to, you can put the 3's before the 4's, but this is fine.